Hi everyone. In today's class, we are going to measure the resistance using the voltage drop method. Objective: at the end of this video, you will be able to measure the resistance using the voltage drop method. Let's discuss the voltage drop method. A voltage drop in an electrical circuit normally occurs when a current passes through the conductor. Any length or size of wires will have some resistance, and flowing a current through this resistance will cause the voltage to drop. Simply put, a voltage drop is a loss of voltage caused by the flow of current. The amount of voltage drop depends on the value of resistance and the amount of current flows through the circuit or the element. Let us discuss with a simple example. Assume you have a 40-watt lamp with an operating voltage of 100 volts. Also, you have only a 200-volt source. Here, you cannot connect the lamp directly to the supply voltage because the operating voltage of the lamp is much lesser than the supply voltage. If you connect a 100-volt lamp to a 200-volt source, the lamp will get damaged. So you connect a series resistor R with the lamp so that 100 volts can be made to drop across the resistor and the balance 100 volts can be given across the lamp. The value of resistor R required to drop 100 volts can be found using the Ohm's law formula R is equal to V upon I. Current I can be found from lamp wattage using the power formula P is equal to V into I. I is equal to P upon V. I is equal to 40 upon 100 equal to 0.4. We get current at 0.4 amps or 400 milliamps. Since the resistor R is connected in series to the lamp, the same current that was taken by the lamp will flow to the resistor R. Now substitute the values of voltage and current in the formula R is equal to V upon I. R is equal to 100 upon 0.4 equal to 250 ohms. Here, we get the resistance value R as 250 ohms. Hence, to make 100 volts to drop, you have to connect a 250 ohm resistor in series with a lamp in this case. Let us measure the resistance using the voltage drop method in practice. Take a 100 ohm metal film resistor. Connect a variable DC source, a moving coil ammeter ranging from 0 to 200 milliamps, and a 100 ohm resistor R1 all in series. Connect a moving coil voltmeter ranging from 0 to 30 volts across or parallel to the resistor R1. Switch on the variable DC source and set the voltage to 10 volts. Note down the ammeter and voltmeter readings. Substitute the values in the formula R is equal to V upon I. Check whether you get the resistor values approximately equal to 100 ohms. Increase the input voltage at different values not exceeding 20 volts. Note down the current and voltage values and ensure you get the resistance value of 100 ohms. Now connect another 100 ohms resistor R2 in series with R1. Connect two voltmeters V1 and V2 across or in parallel to resistors R1 and R2 respectively. Measure the voltage and current at different values of input voltage and calculate the resistance using the formula R1 is equal to V1 upon I and R2 is equal to V2 upon I respectively. If you want to measure the total resistance of the circuit, connect a single voltmeter across or parallel to R1 and R2 together. Find the resistance using voltage and current. Method 2. Voltage drop method using a rheostat. Connect a variable DC source, an ammeter and a rheostat all in series. Connect a voltmeter in parallel to the rheostat. Adjust the rheostat to its minimum position. Switch on the variable DC source. Gradually increase the rheostat for a small distance and note down the ammeter and voltmeter readings. Calculate the resistance value at which the rheostat is held using the measured voltage and current R is equal to V upon I. Adjust the rheostat knob at different levels and calculate the resistance from the ammeter and voltmeter readings. Measurement of resistance using the voltage drop method in parallel circuit. Construct the circuit with two resistors of 100 ohms each parallel to each other with a DC source. Now connect ammeters and voltmeters as per the diagram. Switch on the DC source and set the voltage to 10 volts. Note down the ammeters and voltmeter readings. Calculate the resistance R1 by R1 is equal to V upon I1. R1 is equal to 10 upon 0.1 equal to 100 ohms. Calculate the resistance R2 by R2 equal to V upon I2. R2 is equal to 10 upon 0.1 equal to 100 ohms. To measure the total resistance of the circuit, connect a common ammeter series to the circuit and substitute the values of voltage and current in R equal to V upon I. From this video, you can learn how to measure the resistance using the volt drop method. Thank you. Have a wonderful day.